Solving proportions is also an effective way to create scale drawings. These are geometric figures whose measurements are proportional from one to the other. In this video, you'll see how to use proportions to create scale drawings. Let's start with an example. These two triangles are similar. Use the information provided to find the length of x. Similar triangles have the same shape, but not necessarily the same size. Similarity means that corresponding sides are proportional to each other. Looking at these two triangles, we can create a proportion between the labeled sides. Here is the proportion. 3/7 equals x over 14. Start by switching the terms so that the x term is on the left, like this. We want to isolate x on the left side. Multiply both sides by 14, like this. We are left with x on the left side, and on the right we have 3 times 2, which simplifies to x equals 6. So the side length labeled x has a length of 6. Using proportions to construct scale models is an application of this technique. Let's look at another example. You want to create a scale drawing of the Eiffel Tower, whose base and height dimensions are 125 meters by 325 meters. If the height of your drawing is 1.5 meters, how wide is its base? The ratio of base to height is 125 to 325. This ratio can be simplified if you divide both terms by 25, leaving a ratio of 5 to 13. Here is the equation we need to solve. 5 over 13 equals x over 1.5. First, switch the terms so that x is on the left side of the equation, like this. Next, we want x by itself on the left side. Multiply both sides of the equation by 1.5, as shown here. This leaves x on the left and 7.5 over 13 on the right. Expressed as a decimal and rounding the result, we get x is approximately equal to 0.577. Proportions can also be used to solve geometric problems. Let's look at an example. If triangle ABC is similar to triangle ADE, find the length of x. There are two triangles, ABC, the larger one, and ADE, the smaller one. These two triangles are similar, so their side lengths are proportional. We can form a ratio with these sides, whose lengths are 3 and 7, and these sides, whose lengths are 5 and x plus 7. Here is the proportion. The equation is 3/7 equals 5 over x plus 7. We can use this to solve for x. Since the x term is in the denominator, multiply both sides of the equation by the expression x plus 7, like this. On the left side, we have 3/7 times the quantity x plus 7, and on the right we have 5. We want to isolate x on the left, so we have some work to do. Start by multiplying both sides by 7/3, as shown here. This leaves x plus 7 equals 35 over 3. Subtract 7 from both sides, as shown here. This leaves x equals 4 2/3 when expressed as a mixed number.